Okay, so we're going to talk about moving data between arrays. We're going to write a program that moves data from you to a table and back to you. So the point here is to change data between arrays. Later on, when we get into classes and we start talking about the array class, there are things you can do in there to sort an array, to redo that. Today, we're just going to move data between, and the video here will help you do that. Let me move over here. I'm being recorded right now. Hello, those who aren't currently present, or those who, for some sick reason, are watching YouTube videos on my site so they can make programs. So I made a flowchart for it. We aren't using methods. I had over last weekend I had like rethought it and man, I'm gonna try and do methods, but it's just too much to try and teach in a ram-packed period and still get you towards your Christmas holiday type thing. Uh, this project will be due next Tuesday, so you'll have tomorrow on to work, basically 5 days to get it done. You already know you can do it on your own too, right? We're gonna go through it. If you have questions, please ask. And please ask loudly so that those people who aren't present can hear your questions, okay? So I broke it down into sections, but it is one continuous program. It'll go through the whole program. I do break it down into sections to make it easier to program. The first thing you're going to do in your program is you're going to set up your variables in your arrays. You're going to establish your keyboard, your standard. You can call it whatever you want. I put keyboard up there. Those are my variable names. You have two arrays, and they should not be uppercase like they are. That's an autocorrect thing. So table and inventory should both be lowercase. I can fix that in, well, Alexa can fix it right now. Oh, wow. Maybe I won't because I got the cool things going. Let's see what present. That's weird. Okay, that is kind of interesting. I wonder why it doesn't do it here. Okay, so table and arrays both should be, or inventory should both be arrays, and they should be both lowercase. They are arrays with 10 length. That means they have index of 0 to 9, right? On the first array, which is the table, you're going to put 4 items. The items are a knife, flower, pocket watch, and a Twinkie. In your inventory, again, it's an array, length of 10. You're going to put pocket length in space 1. So first thing you're going to have to do is you're going to have to create the array, and then you're going to have to insert pocket length into the first index position, which is 0, right? You're going to have some strings. These are the strings you're going to set up. The first one is action and action 2. Action we're going to use to record what the user wants, something like take flower. That'll be action. Action 2 is later going to be record to strip the verb take away from the whole thing. And then we're going to have item, which is what it's going to be stripped. When we're going to take action, we're going to strip out the verb, which would take, and we're going to assign that to action 2. We're going to strip out the noun flower and assign that to item. We're going to break those apart. Item needs to be initialized, so I initialized it with nada. That has more to do with the IDE than it has to do with the programming, because our program actually assigns the value, but the IDE doesn't like having it unassigned. Okay, and then we're going to have one called temp word, but you can't guess what we're going to put in temp word. A temporary word that we just need to use for a time being. It's going to be our storage spot for whatever we need to put into it. Does that make sense? We're going to establish some integers, I and j, which are iterators. And we're going to set them at 0. Again, the ID doesn't like not having them set initially. And we're going to make 4 markers, marker 1 through marker 4. I could put those markers in an array, and it would be just as efficient. But I just left a marker 1 through marker 4. If I was doing a ton of programs and markers, I probably would put them in an array. That way I could make a little note card as to what's stored in each spot. And all I'm going to do is they're going to start out at 0. And later on, if I need to, I'm going to change them to 1 to indicate something specific has happened or something has occurred, so that the program will know, hey, that happened or occurred, and if it didn't, it'll be a 0. Does that make sense? So into the program. The program is going to start with a while loop, and probably the easiest way to set up that while loop is up there in your strings to make one string called choice. and set it equal to yes, or set it equal to y. So up in Springs, you'll need to have one added that says choice. I mean, there's a ton of ways you can do it. But what I'm going to do for my while loop is say while choice equals yes, keep going. And I'm just never going to give the user an option to change choice to anything. So every time it goes through the loop, it's going to come back and say, well, choice is still yes because, well, I made it that way. That's the way to make a continuous or an infinite loop. It'll never stop. It'll always bring them back. There are ways to get out of loops, and we're going to talk about that, but you guys already know you can break out of a loop by using break. Okay, so in the program, this is how the program is going to go. It's always going to start by setting all the markers to 0. I'm just resetting them all to 0, and every time I do it, because I'm using the markers to indicate a choice. Then I'm going to go to the table subroutine, which we're going to go to now. That's page 2. So these subroutines, this program is going to be one long program. We don't have methods yet, so it's one long program. The subroutines are just to show you we can take it in small bites. So the table is the first part of the programming, and it's always where they're going to come back to. The visitor is going to come back, or the user is going to come back to the table. And you're going to say, in front of you is a creepy table with the following items on it. Then you're going to have a loop, a for loop set up. The for loop is going to go through the loop. And since we know that table has 10 places, right? You put 10 things on the table, which is kind of funny if you think about it. If we later on we put somewhere a baby gorilla, you could actually stick the baby gorilla on the table because it says there's a spot for it. Unless you were to program saying, no, you can't put baby gorillas on the table. Okay? So ours is going to ask, the first thing it's going to go through is it uses I, that iterator, which is at 0, right? And it says, hey, is the position at table index I, is it equal null? Now, null is important. This is important. If you say, if you're going to make a cell null, even if it's a string, you do not put quotes around it. So when you're looking for null, null is that exception. It doesn't require quotes around it. Okay? So it's going to look for the first thing, and it's going to say, is that spot null? If the spot is no, it's not going to print it. It's just going to jump for the incrementer. But if the spot isn't null, it's going to go ahead and output it to the user. So when you say there's a table in front of you, on it is, it'll say a flower, a pocket watch, a knife, and a Twinkie, right? That's what it's going to say. But all the other spaces in your array, since your array is 10 long, because they're nulls, they're not going to say anything. It's not going to print anything. The worst thing I can see from you guys is a printout that shows 4 items and 6 nulls. Because the user is going to say, what's a null? That's a nasty little evil here. So it's going to go through the loop, and it's going to ask at the end, is I less than table length? And it's just going to keep going until that's done. So that's the table. Does that make sense? So going back to our program, we've gone through table. Now we're going to go through question. Now question gets a little lengthier. Remember, this flowchart, it looks big, but it's not really as big as it looks. I just wrote it very large. I didn't try and hurt your eyeballs by writing things that are small. So next we go to the question. So here's the question. You're going to ask the user, what do you want to do? What's your choice of action? The user is going to input, and they're going to input that variable called action. That's actually a variable, right? And then we're going to convert action to lowercase. Why am I converting action to all lowercase? Yeah, some evil people might use uppercase, lowercase letters to make people's choices wrong. I'm just saying, I've seen it done in this class. But here, we're going to make them all lowercase, so it just makes it easier for us. Mississippi should be capitalized, but a lot of people don't, and I don't want to have to write 2 things for Mississippi uppercase or Mississippi lowercase. If I was writing a spelling program, yeah, I'd be all over caps, but I'm not. Then we run into 3. We're only going to have, in this initial program, 3 actions. You guys will be heading towards writing your game, and if you think about it, these 3 actions are very good actions. The first is inventory. It says what you're on. Now, you'll notice I said, does action start with INV? I could have read out the whole word inventory. But what are the odds of them misspelling inventory? Pretty high because it's a long word and their fingers start going. Then you got inventory because they got the O and the R. That's generally what I do. So inventory. So they can do inventory. They can take. They can drop. Now you could do, if you're programming, like does actions start with take, you could program that to be take or grab or pick up. Do you see what I'm saying? So you could have that if statement have several ors, synonyms of take, which means your program would be far more robust. But right now we're just going to go with take and drop. You can later on add things like eat or use or attack. These are all things you can add and you're going to write. And I will tell you, once we write one of these, not so much inventory, but once we write one of these functions right here, you can copy it and change it to do almost any other verb action. It's just repeating. When we learn methods, that's where you stick a method. Good? So it starts with inventory, take, drop, and then an out. If it doesn't do one of those three things that you tell the user, hey, I don't know how to do that. I'm just a wee program. And you might want to be kind and tell them to inventory, take, or drop as actions, or you can just be evil and make them keep guessing like Zork. They don't tell you what verbs are okay. They just keep making you guess until you use bad words, and then you have a program for that. So let's go to the inventory. That's page 4. So when you write your inventory loop, it's actually going to fall right in this if statement, right? Does that make sense? So basically, this is all going to be right in that if statement. If they said inventory, then you're going to put some kind of comment as you're carrying this, or the following things are in your backpacks, your pockets are full of these things, whatever happens to your statement. You can actually get bored later on if you're hard, and this is for you, Beth. If you're hardcore, you can actually do a randomizer that has different messages, so that it's not always the same message. Yes, sir.
There's two eyes together.
Look. Oh, thanks. I'll kill that. Thanks. So remember, null is always written without quotes. So your for loop is going to look really similar to the other for loop, isn't it? We're going to go through and print out the items in your inventory without printing blank spaces. And yes, she's right. I've got 2 eyes on inventory. So is inventory position I? Null. If it is, they're not going to print it. If it's not, we're going to print it. How many items total are in your program or will be in your program at this point? Go back to the first sheet. How many items total will be in your program? 4. No, there's one other. You got pocket lid. So there's 5 items. There's 4 on the table, 1 in your pocket. Does that make sense?
Yeah.
You can actually, I'm going to show you, we're going to make markers as counters. Again, if you get more robust and they don't have anything in their inventory, you can put a statement saying you got nothing in your inventory by using a marker. But we don't have that. So it goes through the inventory, it goes through that array, puts down everything that, and then it ends that process. So the inventory one is pretty easy, and you've seen it before, haven't you?
Yes.
We're using similar code. Remember, if you handwrite this entire thing, which came out to be like 140 lines, about a third of those are curly braces. If you handwrite or hand poke the entire thing, shame on you. Cut and paste. Reuse. Just remember when you cut and paste to go back and make sure that you change the things that are important to that section. Otherwise, you're going to get some really weird results. So from inventory, that one's pretty simple and straightforward. Now we go to, does it involve take? Take takes a little more time. So they want to take the item. Let's go to take, which is page 5. So in the take program, the first thing we're going to do is we're going to figure out what the item is. We're going to actually strip the item away from our action. Action has a big phrase, right? It has take flour or drop flour, but take flower is take space flower. So we need to strip take apart and deal with the verb, and we need to strip flower apart and deal with the item. So the first thing subroutine we're going to go to is item. This little piece of code you can use multiple times. So let's go to item. It's on page 7. Sorry that you're bouncing around. But again, it puts you in there. And you'll notice item is meant to deal with take or drop. You can program item to do the whole thing or just program it to do the part you're doing. Right now we're in the take part. So here's the if statements. If the action starts with take, so, and that literally is a command in there. I don't give you most of the commands until we get to these two here. If it starts with take, you're going to go, temp word equals take space. The space is very important. Remember, we've got take space flower, right? If I'm taking space flower, I wonder if it lets me, no, it doesn't let me do any cool things. Oops. So if I have take, I got to have a space there. My goal is I'm going to strip the word take from it, and I'm going to leave item as just the item. So I need to strip the word take and the space. Does that make sense? So the next thing I'm going to do is I'm going to say item is action.replace all. It's something we haven't used yet. Replace all sounds just like what it says. It has 2 parameters. The first parameter is what you're replacing, and the second parameter is what you're replacing it with. Now we're going to replace it with temp word, which we've set up here was take space, right? And we're going to replace that with nothing. We're going to take that take space and replace it with absolutely nothing. So we've stripped away the take. So item now equals just flower, doesn't it? And action 2 equals take. So we've stripped away, we've taken an action that says take flower, and we've stripped the first part off and made it take, and the second part made it item. We do have the same program for the drop program. Now it's your choice. You can put just this space, this first one, under the take program, or you can put the whole thing. It's up to you. But you're reusing basically the same code with the drop part of it. Does that make sense? If you think about it, not a lot of coding then. It's an if statement with an if it is, then do this, else don't do anything. Yes? All right, back to page 5. So page 5 is our take. We've got the item. Now we're going to see if we're actually carrying the item or if the table has it. So they're taking an item off the table, right? We've got to see if it's really there. So our program is going to loop through with a for loop, and it's going to look for the item in the table. So it's going through that table array, all 10 spaces, and it's going to look. It's going to go through it. Hey, does the position 0 have the item? No, then increment I plus plus, right? Then keep checking. If it's not on the table and it runs down, here's what's going to happen. If I find it on the table, it's in the array, it's going to say, whoa, it is there. And I'm going to set marker 1 to 1. So marker 1 tells me if the item is on the table or not on the table. The minute it does that, I'm going to break out of the loop. Why am I going to break out of the loop? And break is written as literally break semicolon. That's the whole. Why am I going to break out of the loop and not keep searching? Because I found it. If I have an array that's 100 places long, and I find the item in the first 3 places, should I keep searching the array? No, I'm using up valuable computer time that I can be doing something else with. So all this does is break us out. We're going to get to better sort and search programs, but that's later. Some really crazy ones. And those algorithms mostly exist. People have already written. Okay? So it checks. Now, we've got another if statement. Hey, does marker 1 equal 0? If it equals 0, what does that mean? It wasn't on the table. It wasn't in that array. So it's going to say, hey, that's not on the table. You can't pick it up, and then it's going to end. Now, if it is not, so it means it's on the table. We're going to go to the table to inventory subroutine. This one is going to take us to where we're actually changing the array. We're taking something off the table array and putting it into our inventory array. Does that make sense so far? So let me go here past that. So we're using one, I called it a table to inventory subroutine. I have another one later on called inventory to table subroutine. What is the difference in the two?
You're moving the table array into the inventory array to table to array, and then inventory to array, you're moving the inventory.
It's the exact same program except you're going to change table and inventory between them. Does that make sense?
Yes.
Okay, and this one will work for everything. It does not sort your arrays. It does not alphabetize your arrays. That's coming. That's the array class. That's coming, but we're not yet. Okay. So this one does another for loop, and this for loop says, "Hey, is table I equal to that?" We're finding the location of the item on the table. Before, I already checked and found and made sure it was in the table, right, or in that array. Now I'm going to find out which position it's sitting in, and I'm going to use that. So it's going to sort through until it finds it. Then it's going to set marker 3 to 1. Marker 3 says, hey, I've located the item on the table. And when I break, I'm actually going to retain the index of I here. I'm actually going to retain that by doing this. Instead of having to write something else, my table I is now actually set to the location of the item, isn't it? The next thing it's going to do is it's going to find an empty spot on your inventory. So now we're searching for null. Remember, null is written without quotations. We're searching for an empty spot. The first one we find. And we're going to stuff it in there. So it goes through and it looks for an empty spot. As soon as it finds an empty spot, it sets marker 4 to 1. What happens, do you think, if marker 4 is 0? What does that mean?
And it's going to say you have no room.
Yeah, you're already carrying 10 things. Even if Baby Gorilla is one of the, for some reason, video games you can carry a stupid amount of things. I have a character that's carrying around like 2 stacks of 200 groups of ore. Basically enough ore to make like 100 sets of armor. But he's masculine, and for some reason his backpack holds all this stuff. Even if he's feminine, I have some feminine characters, they can hold the same amount. So it's pretty amazing in a video game what you can carry around. You have 10 items. A knife, a fork, an M1 tank, and these roll in your pocket. Oh, that's a big M1 tank. This one did go onto another table, so let's go down and find out what happens. So now we go into some statements. The first one is kind of a way to deal with exceptions. It shouldn't happen because you already checked, it should already be there. But I put it in here. So if marker 3 is 0, that means there aren't any of those on the table. They couldn't find it. That's only an exception handle. Because we shouldn't got to this far if there was not any of those in the table, right?
Yes.
Then checks marker 4. If it's 0, that means your backpack is full, or your pockets are full, or whatever you're doing, they're carrying, they're full. And it'll say, hey, you can't carry anything more. If not, it's going to look, and it's going to say, are marker 3 and 4 both 1? Now I'm going to use an if statement that includes 2. So how do I do the both command? I want to say marker 4 equals marker 4 and marker 3 equal 1. The two ands, the 2 ampersands. We'll do that. So where it says both, put your double ampersand there with your pencil. Where it says both, put your double ampersand. Because that's really what it's looking for, right? Mm-hmm. So if it's 4, if both those are true, I'm going to put a statement saying, hey, you're now carrying a tuna fish. Congratulations. Then the next thing so it's going to have a statement saying you're carrying this. The next thing it's going to have to do is the table. Now remember, I and J, did you pick up on that last one that it was J? Sorry, I didn't stress it. I and J were left where they equaled, right? So now for table position I, wherever that index ended, I'm going to change that cell to null. For inventory J, wherever it left an open space, I'm going to put the item in that spot. Does that make sense?
Yes.
So we just basically swapped the items and did a little user input. We're gonna go back way up here to that and go to drop. Now, what do you think drop is gonna look like?
Basically the same thing as tape.
But
Almost, but
You don't make
You
it
just put your drop.
we're gonna do exact opposite. I could go through those. I'm not going to. They work exactly the same. Remember when they asked both? That's the ampersand. If you decide to use some word more than take, like grab or steal or whatever, remember you can stick that in your if statement by doing if it equals take or steal or grab. You can use that double pipes to have more words that are active, but you only have to have the 3 for this assignment. But think forward. What you're doing right now is creating an engine that you can use in your final project, which will be your island. Okay? This is due Tuesday. Do you have any questions? I mean, I can go through the drop routine with you, but it's pretty much exactly the same routine. Does that make sense?
Yeah.
Ask questions as you go. I'm going to say that as you go, your IDE is going to kick up errors all the time as you keep writing. Don't sweat it too much. If you know you're writing it, run it through. Run what you can as practice, but realize there's going to come a point where you can't run it as practice. It'll eventually break, but you can run it and test up to that point. Does that make sense? Don't panic over errors. Curly braces. Oh my gosh, keep track of your curly braces. There are a lot of them. That makes sense? Right here, instead of if, I could use a switch, but the switch would be very long and kind of difficult to write. It's easier just to make it if statements.
Okay.
Because it allows you to rewrite these ifs to do something else in the future. If you want to use throw or use, or that same statement can be used in the future to do another action. Does that make sense? Any questions? With that, ta-da, I'll end the recording. You can say hi if you want to. Nobody's gonna say hi to it?